got the homework done. We just took up a lot of time with the phone, so who knows? We'll see. But we are going to finish 1.5 today. Tomorrow, Monday and Tuesday, we will be doing the test review and then the test on Wednesday. Another homework check on Tuesday next week. Okay? So let's get started. A lot of what we're talking about today, you're going to remember from, thank you so much. A lot of what you'll hear about today, you might remember from Algebra 2 and from the beginning of the year, because we're factoring again, okay? So let's just point out that when the radicand is negative, so let's go back to that word. Radicand is the number under a radical. It's said to be an imaginary number. So real basic idea that when you have a -1 under a radical, we do the square root of 1, which is 1, and the fact that there was a negative underneath just makes it an I, 1I, and we don't really write the 1 in front. It's not wrong, but I is just a variable. You guys know we don't put numbers in front, 1 in front of a variable, okay? What -1 under a radical is not is a -1, and that's a really common mistake. A negative under a radical does not make a negative on the outside, okay? So, again, if I gave you the square root of 4, you would say the answer is 2. Hopefully, you could do that. The square root of -4 is simply 2i. That's the only difference, okay? Imaginary numbers. So this one is considered a real number. This one is considered an imaginary number. Okay? When you put them together, it makes a complex number. Okay? So a complex number is written in the form of a plus bi, where a is the real number and bi is the imaginary. And it's just like slope-intercept form. When you have to put something in slope-intercept form a million times in your life, it was a certain order you put things in. Standard form has a certain order. Same thing. It's just the order. You put the real number first and the imaginary number second. Okay? A lot of times I don't use her stuff, but I want you to write one thing in here, just as like a workspace that's going to kind of help us understand something, just to write something here. Degree, we already talked about what a degree is. I'm not going to write that here. I'm going to write something else. But let's remind ourselves, yesterday we learned that a degree is the biggest power of a polynomial. So you can have a cubic or quadratic, whatever the biggest exponent is, right? But more importantly, the degree gives us super important information. I've said important like 10 times in a row. It gives us very important information about the polynomial, okay? Your degree, let's make this an equals the number of factors and or zeros. So the degree will give us the number of factors and number of zeros. So however many factors we have the same number of zeros. Remember, zeros are just our x-intercepts. Roots is another word, solutions, x values, lots and lots of words for the same thing. So I'm going to remind you of this in a minute. So this is something that is going to come up again and again, so I just wanted us to have that little fact written there. Okay, cross that out. We're changing this. We're going to factor today, and here's the one I want us to factor. So let's talk about factoring, your favorite. The reason I took several days at the beginning of the year to review factoring, give you a quiz on it, give you the opportunity to retake, is because it's so important. And I don't teach it anymore, okay? I'm expecting you guys to be good at factoring because it comes up all the time. I can't keep teaching it. I will be reviewing it as I go over all these examples, but if you find that you are struggling with factoring or this one type, you just can't get it, I want to remind you of what you can find on Canvas, because I had a lot of people yesterday in some of my classes that had been absent. They're like, oh, I didn't know I could find that on Canvas, so let me show you guys again real quick. When you go to my Canvas and you go to modules, always at the top is our most current module. So that's what we're in right now. So if you were absent yesterday, for example, this is where you go to see what we missed. And you can see everything we've done. I really am organized, guys. Date, assignment number, the section, what day of it, notes, homework key, and a lesson recording of me teaching it, okay? Every single day, you can see. Okay, so if you were absent yesterday, you would find yesterday's date. Oh, this is what the notes were, 1.4 day 2. This is where I'll find the homework and the key to the homework. If you were here, you need to go back and look at something, check your homework. It's all there for you every single day. And then there's the lesson of me teaching it. You could use this to review. You know, you're going back over your notes in preparation for a test. You're like, I don't understand this imaginary number stuff. Oh, it's 1.5 day 1. I can go back to the video and find it. Okay. Also, you know, I told you the most current one is at the top, but I will keep them all there the whole year. So eventually there'll be a whole bunch of modules, right? This one is going to be one you might need to revisit now and again. So this was that pink stuff. This is the pink part of your binder, okay? This is copies of all the pink sheets. If you needed to print one, it's okay if it's not on pink paper. And the interval notation, simplifying radicals, and factoring. It'll be there all year. So if you need help with any of the factoring, this is where you need to go, okay? And you don't have to watch my whole annoying video. You can move the little cursor to the one type that you need. But just know it's always there for you. Okay, use it. Use Canvas. Okay, so, and this actually is not one of the ones we learned, technically, all right? This should look similar to you as this one. This is exactly the same thing with just like an extra step at the end. So hopefully you guys are recognizing this as what I used to call the chart problem. I call it the chart problem just for having a name. And it's the short type because there's a 1 in front. You don't have to do bring down the outside too, split the middle, all of that. You don't have to make a chart. That's just my way of doing it. Even if you use the chart method, I don't need to see the chart, okay? But as I'm reviewing here, I will remind you of it. So we are looking for the two numbers that multiply to get A times C, so 1 times -4, and add to get the B value. So you pick up your calculator, use your brain, whatever you need to do, but you would eventually, hopefully, be successful finding those two numbers. You have to find the same two numbers, make both columns happy. And when we were just doing a quadratic trinomial versus a quartic trinomial, we would go right to our parentheses, bring those numbers over, and be done. We're almost done. We're still going to have our two parentheses, and we're still going to bring those numbers over, but instead of x and x, it's going to be x squared and x squared. That's the only difference, really. Bring over the +4 and the -1. Order doesn't matter. And we always want to factor completely. So I hope you guys recognize that this is another type of factoring that's really, really common. Difference of two squares, right? So this can split into x plus 1, x minus 1, right? And if I had given you this question, like if we were working with these factors on that quiz or at the beginning of the year, or even in Algebra 2 last year, you would have said, okay, this one, and this one, it's factored as far as it can go. Because if you remember, I told you at the beginning of the year that you can't do a sum of two squares. You can do the sum and difference of two cubes, the SOAP problems, but when it's a square, you can only do the difference. You remember that? And so you wouldn't be able to do anything to that. But I lied to you. You can factor this, and I'm going to show you how. It's very, very simple to have you understand the simple way, though I'm going to show you a little bit of work. But let me tell you why I lied to you. It wasn't really a lie. In math, we have this set of numbers called the imaginary numbers, right? The complex numbers system. We start introducing imaginary into our real world, but we don't stay in that world for very long. Usually we say no imaginary numbers. Okay, so when we've been factoring up until this point, it was just factoring real numbers. So what you're going to see is when I factor this, I'm going to end up with some i's in my answer, and that means we're in the using complex numbers, okay? So I didn't really lie, but you really can factor this if we're allowed to have imaginary numbers. So let me show you this. So I'm just going to go off the side. You can either watch or you can write what I'm writing, but you will never have to do this work, okay? So if I took this factor and I set it equal to 0 and I solve it, that would be the 0, okay? So factored form, 0 or solution, okay? We've done that before in our life. But what if I was like, wait, I wasn't supposed to solve it. I was supposed to leave it in factored form. The directions say factor, not solve. Well, besides being able to look above, how could I change this back to a factor? You just bring the 1 back to the other side. So opposite operations to cross the equal sign, and it would be back to x plus 1, right? So factored form, 0. So in order to teach you how to factor this, I'm going to do that same thing with this problem. I'm all over the place. So let me use this space over here. So x squared plus 4, I'm going to set it equal to 0 and solve it. So watch. I subtract 4. You'll never have to do this work unless you want to. And then I take the square root, right? To get x by itself, I would take the square root of both sides. So this is what we were just talking about a second ago, that we were going to get an answer of 2i, not negative 2, 2i. But there's one other thing that's really important for you to remember, is that whenever you take the square root of something, what do I have to remember to put in front, Tyler? Yeah, plus or minus. When you take the square root of something, you always get 2 solutions, okay? And let's make a quick connection here. We'll sidestep. This was a linear factor. We got 1 solution, right? X to the first, we get 1 solution. X to the second, we should get 2 solutions. Our degree gives us our number of solutions, or factors, okay? So that should make sense, that we get 2 solutions, okay? So then I go, oh, wait a second. I wasn't supposed to solve it. It should be in factored form, just kind of like I acted on this side. So let me just write it a little bit different, right? Either way that you would write this answer or this answer is the same thing. This is the shortcut of writing this. So if I bring each of these to the other side, subtract 2i and add 2i, now I'm in factored form. Okay, so there, any order, doesn't matter, are our 4 factors. Now let me tell you the shortcut. Whenever we're allowed to have complex numbers, and that's in this chapter right now, I think later on we'd say back to just real numbers, okay? So if we were factoring this later on, we'd probably just stop with this and this. But we'll worry about that later. But how do I do this without having to do all that work? Well, let's do another one. If I had x squared plus 9, for example, I would say, oh, this is almost like the difference of 2 squares, right? If that were a minus, it'd be x plus 3, x minus 3. Here's the difference. When it's a plus, it's still going to be x plus 3, x minus 3, just with an I at the back. That's it. That's it. So you don't have to do this work anymore, but how we recognize these? Simply by sum of 2 squares versus the difference of 2 squares. And we're going to see it like 2 more times here in a second, so we'll go over it again. Okay? But there's our solution. Factored completely. We should have 4. We do have 4. Okay? Good on that one? All right. Let's do another one on the top of the next page. So by the way, that's, 2 more things. That's why I said this. It's a good way to make sure you have the right number of answers, okay? It's important to know that. But I also want to talk about this real quick. Why didn't I have a plus or minus in front of this one, but I did in front of this one? And the difference is really simple. If I just ask you, what's the square root of 4, it's just 2. But if I ask you to solve and I take the square root, that's the difference. That's when I'll have 2 solutions, okay? So this is just really simplistic. What's the answer to that? The square root of 4 is just 2. But solving an equation, so the act of taking the square root to both sides yields the 2 solutions. So notice that difference, okay? This one up here, example 2, factor completely. I am only doing this one really to practice what I just taught you, but also it's that first step of factoring that we always forget, including me. I forget it too. And that's to factor out a GCF. So hopefully you see that they both have a y in common, so I need to factor it out. So it's just the reverse of the distributive property. I'm dividing both of them by y, and that leaves me like that. Okay? So that's all I've done. And if this were on your last quiz, that Algebra 2 review quiz, you would be done. You'd say, oh, it's the sum of 2 squares, I can't factor it. If it were the difference, I'd have 2x plus 5, 2x minus 5. But now that we're allowed to have complex numbers, we will be able to factor this. And you could do those steps that I just did with you, where you go off to the side, set it equal to 0, then move it back, or learn the easy trick. So we'll have 2x plus 5, 2x minus 5 with an I on the second number. That's it. Done. Factored. Okay? Do we get it? The trick? Yeah? Question? We'll do one more in a minute. Little off to the side, conjugate root theorem. These are kind of like freebies. Okay? Even though the word conjugate sounds a little bit scary, your first 5 of 9 homework problems are just like example 3, and it's really, really, really simple. Okay? It's just a concept that you have to get down. It's not difficult. There's no math to do, like arithmetic. There's no calculator work. It's just knowing something. Okay? Conjugates are our friends. They help us so much in math, and we'll use them a lot later on. Right now, we're just recognizing what a conjugate is, and let me try and explain it. And let me fill in these blanks here. She does too much. That if you know that a plus the square root of b is a root. What's that word? Okay, roots. She keeps telling us 0, solution. All those same words. 0, x value, x-intercept. If a plus the square root of b is a root, then a minus the square root of b is also a root. These are conjugates. The sign in front of the square roots are opposites. I'll tell you why in a second. Let me give you another one. If a plus bi is a 0 or a root or whatever, so is a minus bi. These two are conjugates. In front of the imaginary term, we have a plus or a minus. What this is all about is understanding that i's travel in pairs, twos. Okay? Why? Why do i's travel in pairs? For the reason we just talked about. Why is there two numbers from under a radical? Because of that reason. So you can't get a positive I without getting a negative I, because the answer came from under a radical. That's where i's come from, is under a radical. So if I say 2i is a solution, then you know negative 2i is also one of your solutions. Same thing with radicals. What if I gave you this problem? If I said solve that, you go square root, x equals plus or minus, and we'll just leave it as a square root of 5, or you could put it in your calculator and get a decimal. But you're always going to get two solutions, okay? So radicals and i's, when we're finding the solutions, always travel in pairs. Yes? Great question. So his question, Brandon, was, if this was a negative 5, square root, you would get plus or minus, right? All that you could simplify here is the I. The I would come out, but the 5 would be left underneath, okay? So bring the I to the front. Technically, you can put it in the back, but here's why I don't, because I have to really because, we get messy, and on a test, do you want to get marked off because you accidentally extended the radical? The point is, the negative came out and became an I. So you want to make sure you show it on the outside, okay? So maybe you can only simplify part of it. Good? Okay. So here's what the first 5 homework problems are. This is just saying if we have a polynomial function with a degree 5, why are they telling us that? We'll come back to it. And they give us these solutions, find the remaining solutions. There's no polynomial. There's nothing to type in my calculator. There's nothing to factor. It's just knowing this conjugate root theorem, which is, okay, I have 2, 3i, and 1 plus I. That's a whole one root, 1 plus I, okay? So what else? How many more should I have? 2, right? There should be 2 more. Because of degree 5, I have 1, 2, 3. I'm missing 2 of them. That's why we want to know that little rule, okay? So somebody give me one that we're missing. Negative 3i, right? If you have a positive 3i, 100% of the time you're also going to have its conjugate known as negative 3i. How about the other one? Yeah, 1 minus I. If you have a 1 plus I, you're going to have 1 minus I. Notice I didn't change the sign of the 1. I's travel in pairs, not regular old numbers. That's why I didn't have a negative 2 as another solution. 2 is just a 2, okay? But i's and radicals travel in pairs, okay? Easy, right? That's the answer. Done. Tomorrow we'll go further with it, but today you're just doing that part. All right. Almost done. Yuck. I did that problem. I do every problem that we're going to do ahead of time. That's why I don't sleep ever. Maybe next school year I'll sleep after I've already done all the work. But I started doing this problem. I was at 20 minutes, 25 minutes just doing step A and step B. She can be really over the top. And that's not even something worth, it's in the, whatever. You don't have to worry about it. Okay, this is worth our time. I'm changing the problem. If you want to write the directions, that's fine. I want to touch on a topic that I want to finish touching on a topic I touched on yesterday. Whatever. Okay. Okay, thanks. So I started talking about multiplicity yesterday, and I wanted to talk about it a little bit more, which will help tomorrow be a little bit easier. Dylan, you writing this down? Okay, so what I've done here is I created a problem. I just made it up, okay? And what you're looking at is pretend that we factored and we got to this step, just like we factored that problem earlier. And now I want you to find the zeros, okay? So you'll notice, though, our factors have these powers on them. So you guys know in algebra, a shortcut to writing x plus 1 twice is writing x plus 1 with a 2, right? Instead of writing this 3 times, we have a little shortcut method. But that doesn't change the fact that when we solve this guy, we're going to get 2 of the same answer, right? Because it's really x plus 1 and x plus 1. And y'all know, when you set x plus 1 equal to 0 and solve it, you get x equals negative 1, right? So here's the factor. Here's the 0 root solution that goes with it, right? But because there's a 2, we actually have 2 negative 1s, agreed? We have 2 of them. But instead of writing them twice, when it tells you to use multiplicity, you just say multiplicity, and I just shortcut it. How many of them do we have? 2. That's it. That's multiplicity, guys. Okay? It means we have 2 of them. Students overthink this concept all the time. Okay? X squared plus 4. And by the way, you don't have to show this work. Like, I don't think any of you would have needed to show the work here. You can solve that in your head successfully. So I'm just showing you, because I usually get somebody that wasn't paying attention or something that has the question. Same with this one. I'm going to show the work, but I don't care if you do. Okay? So subtract 4. I get x squared equals negative 4. Square root. We get x equals plus or minus, good, 2i. Okay? Remember, if you're a degree 2, you're going to get 2 solutions. And we did by getting a plus or minus. So you could write them separately, or you could keep them together, either way. But that's really 2 solutions, right? How many of each of these do we have? 3. So this is a multiplicity of 3. So that's actually a total of 6, right? We have 2i, 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 negative 2i, negative 2i, negative 2i. Okay? Shortcut way of writing it. And then, of course, I'm not going to show the work on this one. We would get x equals 1, right? Set that equals 0 and solve, we get 1. What's its multiplicity? 1, right? That's the most common multiplicity. That's why you probably haven't seen it till you got to algebra, because algebra 2, because you didn't solve higher level degree polynomials. You stuck with solve 4x plus 7 equals 10. You solved 1x equations. But so that is all multiplicity is, okay? And it does affect how a graph interacts with the x-axis, and we will talk about that tomorrow. But I just wanted to kind of remind you of this. What's the degree of this polynomial? I'm not going to make you write it, but what would the degree of the, make the connection? Anybody? Close. 9. William, remember there's 2 of them. Yeah? So 3 2i's, 3 negative 2i's, 2 negative 1's, and a 1. So if we have 9 factors, 9 solution, it's a degree 9. It works both ways. So this would be some crazy polynomial. I just made it up, okay? All right, one last problem, and then you will get to go work on homework. Example 5 and example 6 are almost identical. I mean, they're the same type. So if you wanted an extra one to practice, not assigning it, remember, when I write that, that does not mean you have to do it. It's just a good one. It's me saying that's a great example if you need more, okay? But I'm going to do example 6 with you, which is just like it, and then we'll go to the homework. So let me read. The complex number z equals 2i is a 0, okay, thank you, of this polynomial. Find the remaining zeros of f of x and factor over complex numbers. Okay, so they're giving us this polynomial. You all know I can't write that small, so I'm going to rewrite it right here. And I think you guys know I can put the equal sign on this side, right? It doesn't matter. And since I'm trying to find the zeros, f of x, which is y, is 0. So whenever you see them change that, I remember being your age and wondering why did it become 0? Remember, what we're finding are x-intercepts, 0, solutions, roots, all that stuff. So when you are on the x-axis, your y value is 0. So what we're asking ourselves is what is x when y is 0? That's basically the question we're asking here, okay? So that's where that came from. So what this is, how many solutions are we going to have? 3. It's a degree 3. They gave us one, which is kind of dumb. I don't know why they did. The only benefit to having that is to check our answer. What we should know that when we're done, one of our 3 answers should be 2i, which means we already know one of the other answers, which is what? Negative 2i. So we know 2 of the 3 answers, but we can't just guess on the 3rd one. I don't even know why they give that to you. Okay, so this is one of our 4 terms where we group 2 and 2. Okay, back to factoring, and then you do your GCF business. So 4 and 10 have a 2 in common. That's their GCF. And they have x's as well. Remember, we take the smaller number of x's. So that would be x squared. And primarily what we're doing is just dividing both of these terms by 2x squared and getting whatever's left over in the parentheses. It's really the reverse of the distributive property. So we get 2x plus 5. You could check it by doing the distributive property. Don't forget, my darlings, when the 3rd term is negative, you factor out a negative, okay? Something you'll see in the homework. So if this had been a negative 16x, my next thing I would write is a minus, okay? But it's not. And if you're having trouble finding that number, let this help you. You know that these parentheses in the end should be the same, right? So I know this should be a 2. So if I divide 16 by 2, I get 8. That can kind of help you. And they don't have any x's in common. So I'm just dividing both of these by 8, which does give us identical equations. Remember, that's what we're looking for. And then we go right down to any order. Our identical twins can go in either set of parentheses. It does not matter. And then our GCFs go in the other one. Okay, so this is pretty much factored, right? But we want the zeros. This one's really easy, right? Subtract 5, divide by 2. You could make it a decimal or a fraction, but we would get negative 5 halves or negative 2.5. However you want to write that answer is fine. So there's one of our 3 solutions. Well, we already know the answer, don't we? We know 2i and negative 2i are there too, but let's prove it. I'm just going to use this space. You guys know I write so big. Subtract 8 from both sides. Divide by 2. How many times are we going to do the same problem? Right? Square root. Square root. So our 3 solutions, x equals plus or minus 2i and negative 5 halves. There are my 1, 2, 3 solutions. So the 2i, you'll see them do that in the homework too, give you one of the answers. It's a good way to know that you did it right. You didn't want to look up at the key. But I just always want you guys to remember, because it's so easy to forget the plus or minus. It happens all the time by my students. So just remember to just have that last little check at the end. Degree 3, do I have 3 solutions? Oh, I forgot my plus or minus. Easy to add back in. Okay? Good? Okay. Any questions? All right, so find practice set 1. Find it in all your paper. A14, 1 through 5, 11, 12, 15, 16. And guys, 1 through 5 is just knowing the degree. What are the rest of the zeros? Your conjugates. I's travel in pairs, radicals travel in pairs. Okay, so 1 through 5 should go back pretty fast. Does everybody have the assignment written down? Good. Okay. So these are just like example 3, I think it was. Give me a second and I'll come around and help. I am going to give extra credit to those of you that have your formula sheet. In your binder form, and I'm just walking around just real quick. Once you show it to me, there's nothing that matters. You will do it better if you read it. Okay, great. One time, in the binder. Extra credit. Easy to get extra credit by doing what I asked you to do, which is just have those pink sheets in the front of your binder, not stuffed in your backpack or anything else. Uh-huh. Yeah. Are we getting these?